Do you guys think physics has anything to do with any sports at all?
No, I guess it's the talent.
So it's just the player skill?
It's all messy, bro.
Your technique.
Okay.
Kashani.
Alright. So you guys don't think physics has nothing to do with it?
Let me just Google that.
It's all messy, bro. It's all
I think
messy.
it's the quality of Google has the answer.
So what do you think is the reason soccer ball curves when it's in the air?
I don't know, I guess how a player hits the ball.
So you're basically saying it's the skill?
Yeah, obviously, what else can be a factor?
So why do you think a soccer ball curves when it's in the air?
Well, I would say it depends on where you kick it from. I mean, if you kick it right in the middle, it's not gonna curve anywhere, it's just gonna go straight. But once you kick it from one of the sides, either the left or the right, it's either gonna curve this way or this way.
Okay, so what do you think is the reason behind the soccer ball's curving?
It's the momentum, the change in momentum when player kick the ball, it hits the ball, and the side which have force on it, it causes to curve.
Force.
Or force, it called the impact. I don't know which force.
So, as we can see, we're quite unaware of the physics involved in our daily sports. As a result, today we're going to be talking about physics in sport, in particular the physics behind soccer. So, let's take a look at this video. This was a historic goal scored by David Beckham against Greece in the 2002 FIFA World Cup qualification matches. If you analyze the video, we can see that the ball curves a bit towards the end. Now, why is that? Aren't soccer balls supposed to go straight through the air?
Or should they?
So this is called curving the ball, due to obvious reasons. When a player wants to curve a ball, he does not hit the ball to the dead center. He hits it a bit to the left or to the right, depending on how he wants to curve it. Now, the spinning ball encounters the airflow, and here's when things get really interesting.
Due to the spin, there's one side of the ball where the directions of rotation and airflow are conflicting. Due to these conflicting directions, the velocity of the air here decreases. On the other side, however, these two directions are the same, so the velocity of the air will increase. Now, Bernoulli's principle states that when the velocity of air increases, its pressure decreases. We can also interpret this to say that when the velocity of air decreases, its pressure increases. Looking back to our example with the ball, we can see that one side of the ball has a higher velocity than the other side. The side with the higher velocity should have a lower pressure, and the side with the lower velocity should have higher pressure. Due to these differences in pressure, the ball experiences a force towards the side with the lower pressure. This force is called the Magnus force, in honor of Gustav Magnus, the person who discovered it and explained it. According to Newton's second law, the ball should accelerate since there is a force exerted on it. Now if we look at the overall path of the ball, it will be a curve since it's accelerating sideways at the same time it's moving forward with the velocity.
To illustrate this in another way, let us give you a demonstration. So here, what I have is a hollow paper cylinder. What I'm going to do is I'm going to roll it down an incline, and as a result, it's going to spin this way. What that's going to do is it's going to create high air pressure on this side and low air pressure on this side. As a result, instead of the cylinder falling down straight, it's going to curve towards me. So here we go.
If I want to curve the ball, he doesn't hit it to the dead center.
So how does the spinning of the ball
Air cylinder. Oh my god!
Oh, the air cylinder?